You type out a request and hit enter. Within seconds, an AI chat interface responds with structured, thoughtful paragraphs. While the interaction feels like a conversation between humans, the model does not read your sentences or comprehend your words. The moment you submit a prompt, a translation layer intercepts the text. It breaks the message into the microscopic computational units required for the model to function. These units are called tokens. This hidden token layer dictates how AI generates text, why it occasionally loses track of earlier instructions, and how the platform calculates the cost of every response. We can track this process using a simple example. Generative AI is amazing. The system immediately chops the sentence up. It isolates generative, AI, is, amazing, and the exclamation point into distinct blocks. Complex or long words undergo further fragmentation. The word tokenization drops down and neatly splits into two smaller blocks, token and ization. Processing whole words alone is inefficient. A model would struggle with every new typo, slang term, or rare name it hadn't specifically memorized during training. However, breaking text down into individual letters is too granular, making the mathematical processing slow and resource-heavy. Modern AI uses subword tokenization as a middle ground. It keeps common words whole while fracturing complex ones into their component parts. Once processed, your prompt is no longer a human thought. It is a standardized sequence of mathematical units. These units move from the translation layer into the processing core, where the actual generation begins. If we view language as a structure, these tokens are the bricks. The AI's job is to analyze the specific ways these bricks connect to one another. This diagram shows the generation mechanic. The system calculates the statistical likelihood of every possible next token, then selects the one with the highest probability. As soon as that token is added to the chain, the calculation instantly repeats to find the next piece. The final paragraphs we read are the result of this rapid-fire prediction engine snapping blocks together based on learned patterns. Because tokens are the fundamental unit of the work being done, they are also the unit of measurement for the cost of the service. Every interaction involves input tokens. This includes your current prompt, any files you've uploaded, and the history of the conversation so far. Then there are output tokens, the new pieces the AI calculates and sends back to your screen. Summarizing a long document requires a high volume of input tokens, while generating a long essay consumes a high volume of output tokens. Both increase the total compute time and the associated cost.
Tokens also define the limits of an AI's short-term memory, often called the context window. This illustrates the memory limit. Every token in a conversation, from your first question to the AI's latest answer, fills the window. The rate of consumption varies. While a standard word is 1 or 2 tokens, computer code or emojis occupy significantly more space. When the context window is full, the model must eject the oldest tokens to make room for new ones. This causes the AI to lose track of the earliest instructions in the thread. Recognizing these constraints changes how a professional approaches a long-term project with an AI. It allows you to anticipate when a model might lose its train of thought and monitor how complex data, like code, will impact your usage costs. Using generative AI effectively requires managing the mechanical prediction engine that builds language one token at a time.